This is just a brief look at the Dank dungeons, um, early alpha stuff here, and just working through some things here. So if I hit play, you'll see on the left here that I've got a very simple interface. I can use the arrow keys. I can use this here, turn left, turn right, and it's all in the vein of the old Eye of the Beholder. Actually, my inspiration for it is Phantasy Star on the Sega Master System. It's one of my favorite games, and so I always have enjoyed this kind of tile-based movement. And so when Legend of Grimrock came out, played that a whole lot and inspired to make my own. Didn't really know how to program, so taken time to learn a bit of that. And obviously, there's not much to do here except just walk around in a mostly empty maze. I'll stop that there. Hit play. You can see that what I've got over here is it generates it from a sequence of pieces, starting with a central piece right here. So starting with this central piece, what happens with that central piece, if I go into models, this central piece here has got a few different exits on it, 4 different exits which are positioned here, 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 and here as children. And what the program does, the maze gen program over here, it's got a list of I guess hallways at the moment, and I plan to expand that into hallways and rooms, so hallways can be connected to rooms and other hallways, etc. But rooms can only be connected to hallways, so you can't get kind of rooms springing up next to one another. And what this will do is look at it and just at the moment just picks a random one and attaches it and rotates it and aligns 2 exits together. Now, because of the nature of that, there are some exits like over here where if I click on this, you can see that there's an exit there that hasn't been assigned yet, and it won't be. And in this case, a dead end would be put on that there, or the exit to the maze, or the exit to the dungeon, or the entrance, whichever one. Same with this one here. And what I have, the way I've designed it is originally it wasn't so perfectly grid based. The problem occurring with that is it's very difficult to check collisions between overlapping meshes in Unity. At least I found it quite difficult. Maybe in the future I may be able to do that. So I went with a 9x9 grid, which allows me to get quite a bit of detail into some of these areas here. So it doesn't just have to be straight through intersection. I can add some other detail in there. And what I plan to do is have larger rooms that might be 18 by 18, and but modular though. So the first time the room is created, it will then automatically add the other parts of that room until the room's complete, and then proceed to continue with the exits. There's only 3 modules that I've quickly thrown in here just for testing at the moment, and have put different colored outlines on them. Each of these modules has it's called check collision. It shouldn't be called that anymore, because all it really does is draw the bounds on there. Originally I was using bounds to determine whether or not something intersects, but there is a problem with that. And when you rotate a shape, you'll see that the boundary there gets bigger depending on the rotation of that shape. So that's the boundary getting drawn on the outside there. So it's kind of like a square. The line was drawn across there to there, then that's the widest point of the boundary, and it's aligned with those axes. So that wasn't suitable, and decided to do something else. But it was quite handy just to have those in there. The movement script is written in Boo, and I'll probably change that to Java script or Unity script at some stage. The reason I wrote it in Boo was that I'm more familiar with Python than anything else, and I've just got some basic things up the top here. I'm not sure. I was doing a whole lot of stuff with Counter-Strike at the time that I wrote this, which is probably about 3 months ago. So that's why I've, for some reason, put all these SV things in there. But they can come out, and I can just rename them step size, grid size, etc. I think that was just a habit because I've been doing so much stuff in playing around with the Counter-Strike server settings that I just ended up changing or adding these things in there. And if you've used Counter-Strike server settings, you've got to set all these things for surf maps, etc. So these were just subroutines that run. So turning, and this goes in as right, and it's either true or false. So if right, then it rotates to the right, else rotate to the left, and then it does a slurp between them. So it kind of over the space of a certain amount of time, which is turn speed, so in this case 1 second, over the span of 1 second, it will rotate from the original rotation to the new rotation over the span of 1 second. So that's really cool. Same with move forward. It's forward. Forward is either true or false. So if it's false, it means you're moving backwards. And we've got the new position, and then we lerp between the two. So lerp is the same as a slurp, except without a rotation on it. And then we've got strafe right, and that's pretty much just the same as that one there, except we're just moving to the right or left. I could probably make this into one function that just accepts a direction vector rather than forward, and that would probably be a bit more efficient, but I won't worry about it now. The height of the camera is adjusted with a raycast that always stays. I've hard coded this to 0.6. I should probably change that to a height off the ground, but 0.6 is probably a good height. All the rooms are 1 unit high in Unity, 1 unit wide. So 0.6 is kind of like I guess the equivalent of a person's height in a room. And then we've got the update function down here, and this is just accepts the input, which isn't great at the moment because it doesn't really allow you to change the settings. It's all just hard coded in there. But like I said, this is just for testing. And then I've got those buttons at the top, which I was just testing it to see if it ran on an Android device, and it did, so that was good. Maze generation. We've got the function start, just runs maze gen. It will generate up to a maximum number of rooms, and it's fairly efficient. If I go 250 and save that, and then go back to Unity and hit play, it'll only take a second or two to do this. And so I've got 250 rooms. Now it could be more efficient, of course, but I've got 250 different intersection rooms there, and I wouldn't really want a maze to be this big because it's going to take you a long time to navigate it, especially considering that that's where our little character guy is there, and that's quite a large area with a lot of dead ends. Ideally, there won't be as many intersections. There'll be more hallways and kind of rooms that can be explored without being massive, I guess, just doubling back on yourself. Like if you look at this here, you can go from here to here, then back there, then up there, and down there, and it's just kind of in one big massive loop everywhere for you to get lost in. And I plan to have less looping areas and more defined. This will also give me the opportunity to use more custom designs rather than just randomly generated. It's not really procedurally generated here. It's more just picking random elements to stick together. But it does work well at the moment. And if we go back to here, so what it does is it's just a simple breadth first expansion. We create one instance, that's a central instance. We add its position to the occupied array so that no other instance gets created on that position. Find all the exits, so find child exits of the current instance, and that's a function up here that just goes through all the children. If the child's name is room exit, then we add that to the list of children and return it. Increase the number of rooms by 1, and then while we've got exits left, or the current number of rooms is less than maximum rooms, we shift out the next exit, so the first exit from the list. One thing that this does do is, originally I had attempted to shuffle the exits as it went in, so it didn't just do it, but it didn't really matter because it was going to be breadth first anyway. didn't really matter which order it happened in. Um, if I did shuffle the exits as it was updated, I would get a much less generic looking or kind of expanding array, and probably something that changed a little bit more. So, for example, if I did this exit equals remove at, oh no, I can't actually do that. No, I can do that if I quickly just go rand var rand element. Let's go int equals random dot range from 0 to current exit, sorry, remaining exits dot length, and then I go equals remaining exits. Just have to remember to shift that in there. Move later. Remaining exits dot rand element, and then on the next line, remaining exits dot remove at rand element, because we don't want to leave it in the list. This, if it works, should give me a much less expanding looking maze, one that's a bit more, yeah, see there's holes in it now, there's holes there. If I do a smaller number, it'll probably be more noticeable. Let's see, just go 25. See, it doesn't go out as much. Still not many holes, it's not much difference in shape, but it does allow for, I guess, more kind of arms to spread out from this central location, rather than all being kind of bunched up together. I might just leave that in there for now, and if I do something with just do something crazy and try 500, it might take a few more seconds to create. Yeah, so I get some more interesting looking shapes here. So there's this whole entire gap out here, there's some holes inside there, and if I was to go into the maze gen and say just remove this one, put that one up there, dungeon module, put the turn in there, and just change this to 2, or maybe put the turn in there as well, hit play. So without the extra corners in there, then I get a maze that's a lot less random. Now, because of these flat areas here, it doesn't look as good, and what I really need to do is just keep these flat areas, or at least in SketchUp where I've been modeling this stuff, because I find it pretty quick, reverse those faces so that you can't see them from the top down. They're just there to keep that bounding box the same, so the center is always the same, and it rotates around that center pivot point. But it's a lot more interesting to look at now than what it was before. So if I just go back to what it was before, and where were we looking down here? Remove that. Dot shift. Don't need that line. So if I go back and look at that now with 500 elements, and it looks like it's running out of exits in this case. It's not actually getting to 500, it's running out of exits. So if I look through the list, there shouldn't actually be any exits anywhere that are open. to the outside. No, there's not. But you can see that we've got some more interesting shapes happening, so there's quite a long hallway there rather than um, going off in different areas. Doesn't really matter. I suppose I could just pick it randomly. Doesn't really matter. I suppose I could just pick it randomly from the list. Doesn't really matter to me. So I think I might actually just pick it randomly from the list like I did before. And that'll give me some more interesting shapes in the long run. Now going on from there, we create a new instance. I align it, and then kind of what this does is, because floating point is pretty inaccurate, and when comparing two vectors in Unity, if they're not exactly the same, then they're not going to return the same. It's not the comparison is not going to return true. So this here just rounds it to the nearest number essentially, instead of being like 9 or 8.999999999 repeating. It's just going to round it to 9, and that way I can then check and see if the new position of the object is in the occupied list. Print occupied. Otherwise, destroy that instance. We don't need it, and it will just go through here again. So it'll just create another element, and yeah, I think it just creates another element. No, it pops another exit off. So if it exits occupied, just pops another exit off. It does leave that exit in there. It doesn't delete it, because I want to add a dead end to that. If the other side of it was occupied, I want to add a dead end to that exit there. Otherwise, if it's not printed, it's going to just print adding instance. Don't need that anymore. It's just for testing. And add the new instance position to the occupied list, increase the number of rooms by 1, add all the exits on there, and concatenate it to the remaining list, and destroy the exit. So destroy the exit. When it aligns the room, it also destroys the other exit as well. So this here, it does some alignment with the parent objects. Check overlap doesn't do anything. It was going to do something, but I didn't need it in the end. So that's the start of it. In the next few videos, I'll be adding some more modules, as well as vertical modules. So one of the things you may have noticed about Legend of Grimrock and other things, if you wanted to go to another level, well, it had to load the next level. But this here, the way that it works is, well, if I just quickly add in a game object, I can go up, go down to here, game object, create other cube, just move it to here, and scale this out, make it quite long, and then I'll rotate it up that way. So I've got a little platform here. Now, what my camera will do is it can go up onto it, and I can actually get up on top in this case and look around the maze. I do have a pretty long rendering distance on there, which I don't need. I can cut that back a little bit. But I found that this works quite well, so I can actually have multi-level mazes that go up and down, rather than the single level maze that most of these games are normally set to. And it does that through the ray casting, so it's constantly checking how high it is from the ground and adjusting it to the right distance. So I think it's working really well at the moment, and it looks to be coming along quite promising. I'll probably enjoy playing it if no one else does.